Good day everyone, and today we will be tackling another type of collision which is pretty unique, and that would be explosions. Okay, so in explosions, as you know, they start off at one point, but then with all of the energy will then spread out into multiple sections. Okay, so that's what happens in an explosion. You start off with almost no velocity, or at least the same initial velocity, and all the masses are combined, but then you split up, okay, into how many pieces as dictated, usually two pieces, but I'm sure explosions could have more than two pieces, and then they would all go off on different velocities, but the momentum is still conserved, meaning initial momentum is still the same as final momentum. So in terms of equations, this is how it would look like. M1 plus M2 times Vi, okay, is equal to M1 V1 plus M2 V2. Okay, so in this case, again, all of the masses are initially combined. They go at the same velocity, whatever it is, and then they will then explode, meaning that the velocities will go their separate ways, the masses will go separate ways, and that will be that. For this case, we will go with 0 being the initial momentum, but it could be that the initial momentum is not 0. Like for example, if you're on a tank wherein your object is moving, okay, your object is moving and then you fire a weapon, then definitely your initial momentum there is not 0. But anyway, let's take a look at the problem that we're given. So we have a tennis ball loaded into a cannon. The cannon is at rest when ignited. Okay, immediately after the impulse, the cannon recoils backwards at a certain speed. Determine the post-explosion speed of the tennis ball. So how fast does this tennis ball go? So the first thing that we have to take note of here is the 56.2 grams, because 56.2, while that's something we could use in our calculations, is not an SI unit. Okay, we have to convert it to kilograms if we want to utilize units like Newton, because definitely kilogram would be your SI units. So converting to kilogram, it would be divided by 1,000. So 56.2, or sorry, 56.2, it was 56.5 in the calculator here, but I think it's almost the same thing. It's going to be 0.0562, not 565, 0.0562 kilograms. So let me write that down. So that will be 0.0562 kilograms. Okay, so that's the kilogram measurement in SI units. Okay, now I think we could work with everything else. Okay, the mass of the cannon is 1.27 kilograms. Okay, then we need to look at the speeds. Your Vi is 0, so you're not using a moving cannon, it's at rest. Okay, and then we can now take a look at your speeds of everything else. So Vi, that is the V of your tennis ball. You don't know it yet. V2 would be the speed of the cannonball after the explosion. So it is listed here that there is a recoil going backwards of negative 2.8 meters per second. Okay, so that's the speed at which it recoils. Okay, so you are looking for the velocity of the tennis ball, or V1, and we can simply use the equation that we put out, which is M1 plus M2 times Vi is equal to M1 V1 plus M2 V2. Okay, so let's write that down again. M1 plus M2 quantity multiplied by Vi is equal to M1 V1 plus M2 V2. Okay, but you know that you're not using a moving cannon. It's at rest, therefore the momentum initially is 0. So it's just going to simplify to 0 is equal to M1 V1 plus M2 V2. Okay, now you want to isolate V1 here. And to do that, we could just simply subtract M2 V2 on both sides. It becomes like this. And then after you subtract, you can then divide M1 from both sides. So it will now look like minus M2 V2 all over M1 is equal to V1. Okay, so now that we have everything that we need to solve, let's plug and play, plug and chug, and solve. So that's going to be V1 is equal to, okay, 1.27 kilograms times, okay, V2 is minus 2.8 meters per second. And we know that the top is negative. Okay? And all of that will be divided by the mass of the tennis ball, which is, okay, the mass of the tennis ball is simply 0.0562 kilograms. Okay, so the kilograms from top to bottom will cancel out. You'll be left with meters per second, which is the unit for velocity. Now let's plug and chug. So it's gonna be, get the fraction, okay, negative 1.27 times negative 2.8 all over 0.0562 kilograms, leaving you with, let's press SD to get the decimal, 63.27402135 meters per second. So it's really, really fast. And I think it makes sense because definitely after being propelled by a cannon, your tennis ball will really go far. Okay, so that's 63.27402135 meters per second. And now let's take a look at the sig figs. The sig fig situation calls for, okay, so let's take a look. 1.27, 0.0562, 2.8. So 2 sig figs will be our final answer. That would be 63 meters per second. So that is our final answer, which again makes sense because definitely your tennis ball is expected to go much faster than your cannon after that recoil. Okay, so that is how an explosion collision works. Okay, so I hope that you were able to get a good insight on the main types of collisions, and I look forward to seeing you apply this in the classroom. Take care. Goodbye.